video, I'm going to explain about the numbers representation. See, in our daily life, we are using numbers, right? So, whatever the numbers we are using, that we call decimal number system. But whatever the decimal number system we are using, that cannot be understood by our computer, because we know that computer understand only what? One, that is a binary number. Binary, that is in terms of zeros and ones. That means everything in terms of zeros and ones. So there are different types of number systems are there in use. So there are fully main four things. So first one is decimal number system. That is what we are using in our daily life, the we. And the second one is the binary number system that is used by our system, that is computer system. Third one is octal number system, and the fourth one is hexadecimal number systems. So in this we are going to discuss how the decimal number is going to represent it in binary. Okay, so now first, before going to that, how to convert the decimal number into binary? See, suppose if this number is 16, the number is 16, this is what? This is decimal number. So this I need to convert into what? Binary. So keep dividing the number by 2, and as long as the quotient becomes what? 0 or 1. Now 2 8s are 16, remainder is 0, and then again, since this is okay, this quotient 2 8s are quotient is becomes 0, no, again divide. So 2 4s are 8, so remainder is 0. Again, this is not 0 or 1, so again 2 2s are 4, again remainder is 0. Again the 2 is not 0 or 1, so now 2 1s are 2, remainder is 0. Now whenever the quotient become 1, so or 0, you stop. Okay, now it becomes 1. So now from this direction you take. That means now 16 is equal to 1 1 0 0 0 4 zeros. Okay, 1 2 3 4. Now this is binary. Okay, similarly, let us take one more. Let us take, I want to represent 27. So this 27 is in the decimal. Now what is it in binary? So again, keep dividing the number by 2 until it becomes, quotient becomes either 0 or 1. So 2 13s are 16, 26. So remainder is 1. So again 2 6s are 12, remainder is 1. Again this is quotient is not 0 or 1. So 2 3s are 6, remainder is 0. So again 2 1s are 2, remainder is 1. Now again from the last you take, from this direction. Okay, that means now it is 1, then 0, then 1, then 1. So this is in terms of binary. That means 27, this is the 27 in decimal number system. So the same 27, this is in terms of binary. Now this is, suppose if the number is too large, you keep dividing. So I'm going to take one short method, okay, shortcut. So what you do, suppose in this I am using, for example, 3-bit number. So let us say, so 1 2 4. Now if you add which number, now suppose I want to get, I want to write for 3. I want to write for 3. Okay, 3. Now, if I add which number, I get 3. So 2 plus 1, 3. So that makes 1 1. So another one, this one I don't want. So I will make it as 0. Now this is 3 in decimal. This is 3 in binary. Similarly, let us take 6. Okay, let us say 4 also. What is 4? Okay, 4. Now if I add which number, I get 4. I need 4, so I will make it this as 1. Remaining I don't want. So this is binary 4. Similarly 5. So if I add which number, I will get 5. So if I add 4 plus 1 5, so I will make these two number 1. Remaining is 0. This is 5 in binary. Similarly you make 7. So now in order to make 7, I need all 3. 4 plus 2 6, 6 plus 1 7. So I need all or 1 1. Suppose if I want 8, now if I add all 3 also I get 7, but I don't know. So what I will do? So you go for one more bit. So whenever you go for one more bit, you make it simply double. 1 double is 2, 2 double is 4, 4 double is what? 8. Now if I want 8, so if I add which number, I will get 8. Suppose now only this one I want, so 8, remaining are 0 0. Similarly now I want, say, let us say 13. Now if I add which number, I get 13. 8 plus 4 12. Plus 1 13. So 8 4, this is 1, remaining is 0. So this is 13 in what? Binary. Similarly, let us say for 16. For 16, if I add all these things, 8 plus 4 12, 12 plus 2 14, 14 plus 1 15. I won't get, if I add all 4 bit also, I'll get 5 15. I won't get 16. But what to do? Again, same thing. So you go for one extra bit. 1 double 2, 2 double 4, 4 double 8. So next is what? 16. So now, if I want 16, what I have to do? So simply make what? If I want 16, Simply make only 16 is 1. Okay, remaining 0, remaining I don't want. So this is what? This is 16 decimal, this is 16 in binary, same thing I got. Similar check for 27. For 27, now if I add which number I will get 27, 16 I need, plus 8, 24, 24 plus 4, 28. I don't want 28, 27. So 16 plus 8, 24, 24 plus 2, 26 plus 21. So 16 I need, 16 over, remaining what, 8, 16 plus 8, 24 plus 2, 26 plus 1, 27. This is 0. See, same thing I got. So this is what? 27 in binary. So this is a short. So use 1248 format. Okay. So this is how to convert decimal number into binary number. Hope you people understood. So in our daily life, we are using number, that is decimal number, and just now we discussed how to convert decimal numbers into binary number systems. And these binary number systems, see, whatever the method we just now discussed, converting decimal into binary, that is applicable only for positive numbers. But in our daily life, we are using only positive numbers? No, we are using negative numbers also we are using. So how to convert negative decimal numbers into binary numbers? So there is no such method to represent what negative numbers, but we have three methods to convert negative decimal numbers into binary numbers. Okay, so the three methods what we are using is, one is sign and magnitude, and next one is ones complement. The third method is twos complement. So these are the three methods to represent negative numbers. So why especially to represent these three methods to represent negative numbers? Because we need positive numbers and as well as negative numbers also in our calculation. So sometimes we may come into the situation to represent what? Negative numbers. So to represent negative numbers, so we are using these three methods. Now let us discuss one by one sign and magnitude. In sign and magnitude, as the name itself indicates, the most significant bit, MSB. MSB indicates the sign. Okay, most significant bit. It indicates the sign. Suppose this is sign bit. The sign bit is 0. It indicates a positive number. Suppose if it is 1, then it indicates negative number. Okay, remaining bits represent the magnitude. For example, let's take, for example, say plus 5. Plus 5, how to write? So we know that 5. If I want to get, first convert into binary. Now, if I want to represent 5, which are the numbers I need to make it 1? So 4 and 1 I need to make, remaining what? 0. Now this is 0. Now this bit is a sign bit now. So this is 0, 1, 0, 1. Now this is my least significant bit. This is my least significant bit and this is my most significant bit. So always MSB bit indicates what? Sign. If the sign bit is 0 positive, so this is sign, so this is the magnitude. Okay, so this is my sign and this is my magnitude. So if it is 0 positive, this is 5, 1, 0, 1 is 5, so this is plus 5. Now, how to represent same minus 5 in using sign and magnitude? See, same minus 5, what I will do, minus 5. See, magnitude is same. Magnitude can make this one only. But sign, for negative number, what is sign? Sign is 1. So, this is 1. Okay. Now, this is my sign bit. And this is magnitude. See, magnitude remains same. In sign and magnitude remains same. Only sign bit indicates whether positive or negative. If the MSB bit is 0, it indicates positive. If the MSB bit is 1, it indicates negative. Okay. Let's take one more example. Okay. So now, plus 7. Plus 7 what? All I need 1, 1. Okay, all are 1, 1. 7. 1, 1, 1. 4 plus 2 plus 1, 7. Sign bit is what? 0. This is what? Sign bit. This is magnitude. Same minus 7 what? So same, this is magnitude remains same, this is magnitude, this is 1. Okay, this is minus 7. Okay, this is in terms of sign and magnitude. Okay, now let us see ones complement. In ones complement, so we discussed, we know sign and magnitude. In ones complement, what we did, you take the first, write the, for negative numbers I'm telling, write the positive numbers binary number. Represent the given negative number in the binary only. Okay, positive. Then you take ones complement. Ones complement means change each zeros to 1 and each 1 to 0. That's it. Make it. Okay. Ones complement. For example, now see plus 5. Let us say plus 5. So plus 5. Now I want to write minus 5, but we don't know how to write minus 5. Okay. See, I want to represent what is the negative binary number for minus 5. I don't know. But what we know only for plus 5. For plus 5 what? 0, 1, 0, 1. This is the 5. This is the plus 5. Now here what? Change zeros to 1 and 1s to zeros. If I change zeros to 1 and 1s to zeros, see 0 becomes 1, 1 becomes 0, 0 becomes 1, 1 becomes 0. This is nothing but what? Minus 5. This is minus 5. Okay, let us take one more. Again, same, 7. 7 is in the case, so plus 7, we know that 0, 1, 1, 1 is a plus 7. Now change zeros to 1, 1s to zeros. Here all are ones only. So I am changing 0 to 1, 1 to 0, 1 to 0, 1 to 0. This is your minus 7. This is minus 7. So what is the one thing what to observe? See, for the positive number, again, sign bit is 0. For negative numbers, the MSB bit is 1. Okay, so this is how to get ones complement. So the twos complement, what you have to do, in order to represent the negative numbers in twos complement, first takes the ones complement of the positive number and add 1 to that. Okay, for example, same thing. Let's take for 5, plus 5. Plus 5, I know what? I don't know minus 5. I need to calculate for minus 5. But we don't know minus 5. So, but I know for plus 5. We'll make 0, 1, 1, 1. Okay, the 5, right? This is 5. Now, first I should take what? Take the ones complement of this. So, ones complement is equal to what? Change zeros to 1, 1s to zeros. I did. Now, to this add 1 plus 1. So, if I add 1 to that, 0 plus 1, 1, 1, 0, 0. Okay, this is your minus 5 in twos complement. This is minus 5 in twos complement. See, minus 5 sign and magnitude is see 1, 1, 0, 1. Same thing, minus 5 in ones complement is 1, 0, 1, 0. But here it is 1, 0, 1, 1. Three different representations. Let us take one more example. This is plus 7. Okay, I don't know minus 7, but we know what plus 7. So plus 7 is what? 0, 1, 1, 1. This is. But to that, what you have to do? Take the ones complement of that. Take the ones complement. 1, 0, 0, 0. This is minus 7 in ones complement. But to twos complement, to this we need to add plus 1. So 1 you are adding 0 plus 1, 1, 0, 0, 1. Okay, this is your minus 7. See how minus 7 is in the twos complement. This is twos complement. Minus 7 second magnitude, minus 7 in ones complement. So this is how to represent the negative numbers in three methods. So now you can ask, so which method is using in our computer systems? In the whole world, so in all the computers, we are using this twos complement representation only to represent negative numbers because it's very suited to do all arithmetic operations. But if you use ones complement, so we won't get always the right answer. Even silent magnitude also, we won't get always the right answer. So if you do any arithmetic operation on the negative numbers using twos complement, we'll end up with the correct answer. So we are using all our systems. So we are using twos complement method of representing the negative numbers. Okay. So this is how to represent the negative numbers using these three different methods. So hope you people understood. Now summary is in all these three methods. In all these three methods, MSB indicates sign of the number. See here, MSB 0 positive, 1 negative, 0 positive, 1 negative. Again see here, it is a minus. See sign bit is 1. Positive 0, positive 0, negative 1. Again here also see, positive 0, negative minus. See again is 1. Positive 0, negative 1. So the common thing in all the three methods is MSB indicates sign. Okay, and second common thing is for positive numbers, same way. This is the same method. Keep dividing by 2, write in the reverse order, or use this 1, 2, 4, 8 form. Positive number, there is no change. See, plus 5, 0, 1, 0, 1. In silent magnitude, ones complement, plus 5, 0, 1, 0, 1. Same thing. So come two's complement, plus 5, 0, 1, 0. The positive number remains same in all the three methods, but only they will change for the negative numbers. And in negative numbers also, MSB bit indicates sign. If it is 0, it is indicate positive number. If it is 1, it indicates negative number. Okay. So this is what the number representation in all these three methods, especially the negative numbers. So now let us discuss how to perform addition and subtraction using binary number system, that too especially 2's complement, because when we are performing some operations we may come across negative numbers. So already I told, for negative numbers 2's complement is the best method of representing the negative numbers. So let us see how to perform binary addition and binary subtraction using 2's complement. So for that I have done the 4-bit combination already. So 4-bit means 2 to the power of 4, 16 combination I will get. See again, in all the 3 methods, what? This is the MSB bit, it indicates sign, all this sign. Okay, that means all these numbers, all these up to here is all what? Positive numbers, because all this sign is what? 0, that is 0. Okay, positive number, this is plus 0, plus 1, plus 2, plus 3, plus 4, plus 5, plus 6, plus 7. Now, we don't know negative numbers. Actually, these are what? These are negative numbers. Why it is these are negative numbers? Because MSB of these numbers are 1. If MSB is 1, it is negative. So let us say, so this one, let us take this one. 1, 1, 1, 1. I don't know this. What is this number is equivalent to in the negative? I don't know. So, but take 2's complement. 2's complement means what? Take the 1's complement first, 0. So this is take 1's complement, change all zeros to 1, 1's to zeros. Now to this add 1. So if I add 1, 1, 0, 0, 0. That means this is nothing but is equal to plus 1. Since it is this one, now it is nothing but what? This is nothing but minus 1. This is minus 1. So this is minus 1. This is minus 1. Similarly, let us check this one. Okay. So I'll check this one only. Okay, 1, 1, 0, 1. So this is, I don't know what is that. So you take it to its complement of that. So I get 0, that is first 1's complement, 0, 0, 1, 0. To that add 1. So 1, 1, 0, 0. This is what number? 0, 0, 1, 1 is, see 0, 0, 0, 1, 1 is 3. So this is 3 in decimal positive. Same thing, this is in minus 3. So that means this is minus 3. That is, this is minus 3. That is, similarly, this is minus 2. This is minus 4. Similarly, minus 5, minus 6. Minus 7, minus 8. That means the range of numbers in 2's complement using 4 bits. If I use 4 bits, the range is from, what is the minimum number here? Minimum number is minus 8. So minus 8 to what? So maximum number plus 7. So this is the range of 2's complement numbers using 4-bit representation. Okay. Now let us see how to perform some addition. Okay. Now let us see, I need to add the addition of plus 2 plus 3 before addition. So what are the possible bit we can add? I can add 0 plus 0. 0 plus 0, obviously 0. 0 plus 1, 1, not a problem. 1 plus 0, again there is also 1. But when we add 1 plus 1, 1 plus 1, 2, that is in decimal. But I cannot write 2 because in binary number there is no 2, 3, 4. Only we are on 0 and 1. So when you add 1 plus 1, some bit is 0 and this carry is 1. How we are getting carry when we are adding normal addition, right? Carry side like that. 1 plus 1 is 0, carry is 1. So this is 2. Okay. So this is 1 and 0 is 2 only. See, 1 and 0 is 2 only. Okay. So this is the binary addition formula that you have to remember. Now, if I want to perform plus 2 and plus 3, plus 2 is equal to what? In the 2's complement for positive number, 2 is 0, 0, 1, 0, 0, 0, 1, 0, plus 3 is what? 0, 0, 1, 1, 0, 0, 1, 1. So if I add 0 plus 1, 1, 1 plus 1, 1 plus 1, sum is 0 and it will produce carry 1 to the next stage. Now 1 plus 0, 1, 1 plus 0, 1, so 1, 0 plus 0, 0. Now this is 0, 1, 0, 1. 0, 1, 0 means what? Actually, this bit is what? This bit is 1, 2, 4, 8. So 1, 2, 4, 8. 1 and 4, 5. See, 0, 1, 0 is 5. So that is, this is nothing but plus 5 is equal to that. Means, same thing. If you add 2 and 3, I'll get plus 5 only. Binary also it is proving we are getting the same thing. Now let us take one more example. Now I am to perform plus 4. I want to add with minus 6. I need to add plus 4 and minus 6 I need to add. But we know plus 4 is very simple. Plus 4 is what? Plus 4 is 0, 1, 0, 0, I know. Okay. So now plus 4 is equal to what? 0, 1, 0, 0. And minus 6 is equal to what? That also minus 6 is equal to what? 1, 0, 1, 0. 1 0 1 0. Suppose if you don't know how to get minus 6, very simple. Okay, first write plus 6. Plus 6 what? 0 1 1 0. For this take 1's complement 1 0 0 1. To this you add 1. 1 plus 1 sum bit is 0, carries 1. So 1 0 1. So this is your minus 6. Same thing I got 1 0 0. Now you add these two. 0 plus 0 0. 0 plus 1 1. 1 plus 0 1. 0 plus 1 1. This 1 1 0. 1 1 0 is what? See, 1 1 0 is what? Minus 2. That means, so this is what I got is minus 2. This is as expected only, because normal. Plus 4 minus 6 is what? Minus 2 only. Answer also between the same thing. Fine, not a problem. Okay. Now let us take the third problem. Now I need to add minus 5 with minus 2. I need to add these two numbers. So again, see, either you go for like this, otherwise you don't know. Simply, I don't know my minus 5. What to do? Write for first plus 5, take the 2's complement. Same thing you will get. First plus 5 is equal to 0 1 0 1. Takes 1's complement of this 1 0 1 0. Add 1 to that 1 1 0 1. So this is nothing but what? Minus 5. Same thing got minus 5. So minus 5 is equal to 1 0 1 1 and minus 2. So other terms, other simply same. First write plus 2. Take the 2's complement of that. Same thing you'll get. So this is what? Minus 2. Minus 2. Now add this one. So 1 plus 0 is 1. 1 plus 1 sum is 0. It will generate carry 1 to that next stage. So 1 plus 1 again 0, carries 1. So all three are 1. So when I add 3 ones, 1 plus 1 plus 1, I know only what? 1 plus 1 is what? Sum bit is 0. 0 plus 1 again 1. So it will carry to 1 1. So this is nothing but 3. See, 1 1 is 3. Okay. So sum bit is 1. Carry is generated in the next stage. So that is 1. Okay. So now this is the answer. Actually, I should get what? Minus 7. If I add minus 5 plus minus 2 minus 7. What is the minus 7? 1 0 0 1. The same thing 1 1 0 1. So but here what to do with the carry? Whatever the carry I got, that I need to discard this carry. Why? Because if I include carry, I won't get the correct answer. So whatever the carry you got, this you have to discard, because this is minus 7. Minus 7 1 0 0 1. Okay, this is the one problem. Now let us take one more problem. Now plus 7 and minus 3. Now we know plus 7 is equal to what? 0 1 1 1. Minus 3. Minus 3 is equal to what? 1 1 0 1. Now you add these two. 1 plus 1 0. 1 plus 1 0 sum is carries 1. 1 plus 1 0. 0 plus 0. It is to carry. So 3 1 sum is also 1. Carries also 1. 0. Again carry I am cutting. Okay. So now actually what? Plus 7 and minus 3 what? Plus 4. I'm going to say plus 4. 0 1 0 0 plus 4. But again here also we need to what? Discard the carry bit. Okay. So now let us take one more example. So till now we discussed addition problems, 4 addition problems. Now let us see subtraction. So there is a slight change in the subtraction operation. In subtraction operation, what we need to do is, so whenever suppose you are performing x minus y, so we are calling this, see, which I am subtracting, y I am subtracting. From where? From x. So this will call the subtrahend. The whatever the y subtrahend, whatever you are subtracting, you take the 2's complement of the subtrahend. That is the thing in the binary subtraction. Take the 2's complement of the subtrahend. Now, whatever the problem. Now let us take minus 7 and then minus 3. Okay. Now I am performing minus 3 minus 7. So minus into minus plus 7 only. Okay, so that is addition only. Now, what are the, according to rules, always we need to take subtrahend 2's complement. 2's complement of the subtrahend. Yet subtrahend is minus 7. This is see. If I get 2's complement of plus 7, I'll get minus 7. If you get again 2's complement of minus 7, I'll get plus 7 only. Okay, for example, 7. If you get 2's complement of that, you'll get minus 7. Again, you apply 2's complement, that you'll get again plus 7. So minus 7 you get 2's complement, I'll get plus 7 only. So minus 3. Minus 3 is equal to what? 1 1 0 1. So now I have to add only. There is no subtraction actually. We have to adding. But how to add? You add the first number from which number you are subtracting with the 2's complement of the subtrahend. So 2's complement of the subtrahend is 7 only. So 7 is equal to 0, 1, 1, 1. So this is 1 plus 1, 0, carries 1, 0, carries 1. So 3 ones, sum is 1, carries 1. Again 1, 1, 0, carries 1. So again I am getting carry, but minus 3 plus 7. Plus 7, what is the result? Plus 4. I get in the plus 4. That means again I need to discard what? The carry bit. Carry bit I need to discard. Okay. Now we need to subtract 6 minus 3. Plus 6 minus plus 3. So this is straightforward. Just plus 6 I know 0, 1, 1, 0, and then take the 2's complement of the subtrahend. Subtrahend is what? 3. Subtrahend is 3 means plus 3. You take 2's complement of it, you take minus 3. Minus 3 is this one. So minus 3 is equal to 1101. Now you have to add only 0 plus 1. 1, 1, 0, carries 1, 1. This is 1 plus 1 is sum is 0, carry is 1. So now here again 6 minus 3 is what? Actually 6 plus 6 minus 3 is what? Minus plus 3 only. I am getting the plus 3 only. Again I should, this is the correct answer if I will discard the carry, the final carry. Okay. This is another example. Now I need to subtract minus 7 minus 5. Okay. Now plus minus 7 I don't know. Take the 2's complement of minus 7. So minus 7 is equal to what? Minus 7 is equal to 1001. Now take 2's complement of the subtrahend and add that. So minus 5, if you take 2's complement of minus 7, plus 5 only. So plus 5 is equal to 0, 1, 0, 1. If you add this 1 plus 1, 0, carries 1, 1, 1, 1. See, I didn't get what? Carry bit, but answer is correct. This is a negative number. We don't know negative number. 1, 1, 0 is what? 1, 1, 0 is minus 2. This is minus 2. Minus 7 plus 5. How does that get? Minus 2 only. Yes, I am getting correct. Okay. So here I didn't get. See here I got the carry bit. But here done with the bit. But the answer is there. See, whenever the answer falls within this range in the 4 bit. See, all the examples are 4 bit only. If the answer lies in this range, so this is absolutely fine. No problem. Nothing to worry. Okay. So let us take one more last example. So now I need to subtract plus 1 from minus 7. So again I know minus 7 is what? 1001. Subtraction, how to do subtraction? Again I am telling. So take the 2's complement of the subtrahend and add with the summand. Okay. So now for the plus 1, take the 2's complement, that is nothing but what? Minus 1. So minus 1 is equal to what? All ones, 1, 1, 1. Now you add this 1 plus 1, 0. Carries 1, 0, carry, 0, carry. When 3 ones, 1 and then carry. Okay, now this is what? 1001 is what? Minus 8. And this is what? Minus 7. Minus 7 plus 1 what? Actually I should get what? Minus 6. Minus 6 is what? 1010. But if the answer is not false in the range, so it is a wrong answer. So the answer not comes in the range, so answer is wrong. That is the problem. Okay, so now I will do the summary. So here sometimes I need to consider the what? Carry bit, the last final carry. Some most of the case I need to discard. Let us take the one more example last. So let us take plus 7 plus 4. Both are positive numbers only. Okay, this is also plus 7, this is also plus 4. When plus 7 plus 4, that is 0, 1, 1, 1. 0, 1, 0, 0. If you add this, see both are what? Positive numbers. Add 1, 1, 1 plus 1, 0. This is 0, 1. See, I didn't get any carry bit. But still answer is wrong. Why? Because when I add two 4-bit numbers of positive numbers and I am getting the negative number because the sign bit is 1. Sign bit is 1. See 1, 0, 1, 1 is what? 1, 0, 1, 1 is minus 5. I am getting minus 5. This is equal to minus 5. If you add 7 plus 4, I should get 11. But I am getting minus 5. This is the problem. Okay. So, and then when the overflow occurs, see here the sign of the two numbers what I am adding, these are same sign 0, 0. But the sign of the result is different. So when the sign of the two numbers what we are adding is same and the sign of the result is different from the sign of the two numbers, so then your answer is wrong. Okay, so that means that time it is not falls within the range, so that time we are not getting. Okay, so that's the one indication. So whenever we are performing the addition operation or subtraction operation, so the sign bit of all the numbers, both the numbers and as well as the result should be same. So if you observe, see, both are say positive, answer is also positive. Fine. Okay, now here again, so there is one more example here. See, both are negative. I will get the negative only. So this is fine. Suppose if the sign of the two numbers and the result is there different, so the sign of the result is there different, then the answer is wrong. So for that, what we'll do, we go for sign extension. Sign extension means same 8 bits, see, same 4 numbers. Okay, this is what, for example, this is 5, this is 5. For 5, now for 5 actually what, 0, 1, 0, 1. But same 5 I need to write in using 8 bits. But this is the sign bit, extend the sign bit. How many times you want to extend the sign bit? Now that means this is a sign bit 0. That I extended, how many bits I want, that one. Okay, similarly let us check. Minus 7. So minus 7 is what? 1, 0, 0, 1. So this sign is 1. If you want to represent the same minus 7 in 4 bits, you extend the sign. Sign is 1, 1, 2, 3, 4. Now this is sign extension. So total 8 bits are over. This is called a sign extension. So in this, if you do sign extension, then you get the expected answer. Okay. See, overflow occurs whenever we are adding the numbers having both the signs. See, both are having the negative number, I'm getting the overflow. Okay, so again, I'm adding, so both are say different numbers, so then I'm getting different number. Okay, so that is the indication of overflow. So overflow occurs when we are adding the two numbers on the same side, and if the result is not within the range, then that is the indication of overflow. So hope you people understood how to perform addition operation and subtraction operation using binary number system, and how to represent negative numbers in 3 different ways. Okay, so if you have any questions or if you have any other problems other than this one, you please write it in the comments. Thank you. Thanks for watching.